This is pre-calculus section 5.3 on solving trig equations, and we're going to start off with solving some equations. First one looks like this. We want to isolate the variable by itself, so I would add root 3 to both sides and then divide both sides by 2 to get that the cosine of x is equal to root 3 over 2. That's a positive cosine, so my answers are going to be in the first quadrant as well as in the second quadrant. In the first quadrant, the place where that happens is going to be pi over 6. The cosine of pi over 6 is root 3 over 2. And then if I put that same reference angle down in the fourth quadrant, I look at how big that angle is. Basically, I'm taking 2 pi minus pi over 6 and getting a second answer of 11 pi over 6. Second problem, subtract 1, divide by 2. Now we have sine of x is equal to negative 1/2. And if I think about where that takes place at, sine is negative in the third quadrant and fourth quadrant. In the first quadrant, I know that the sine of 30 degrees or pi over 6 is equal to 1/2. So I'm going to put that reference angle in the third quadrant as well as the fourth quadrant. In the third quadrant, that's going to be pi plus pi over 6, which gives us one answer of 7 pi over 6. And then in the fourth quadrant, we're going all the way around, and we're just pi over 6 short of making it to 2 pi. So 2 pi minus this pi over 6 gives us the other answer then of 11 pi over 6. Next example. We have a little bit more going on in this one. The first thing we're going to do is simplify this one. 2 times the sine of x, cotangent is equal to the cosine of x over the sine of x equals root 2. And then I notice that there's a sign in the numerator, a sign in the denominator, so those will simplify out with each other. Divide both sides by 2, and we get that the cosine of x is equal to root 2 over 2. And before I go any further, I need to see that from the original problem, there was a sign in the denominator, which means that the domain would not include any place where the sign was equal to 0. So I want to make sure that I consider that at the very end. We'll come back to that. Cosine of x is equal to positive root 2 over 2. That's going to occur in the first quadrant as well as the fourth quadrant. My reference angle is going to be pi over 4. I know that's where cosine is equal to root 2 over 2. And then in the fourth quadrant, the angle would look like this. So we're taking 2 pi minus pi over 4, and that's equal to 7 pi over 4. Getting back to the earlier discussion about domain, I can't have sine be equal to 0 because of the original problem. That doesn't happen for either one of those, so I'm pretty confident my answer is correct then. Next example. Now we have more trig functions involved. We have a cosine, we have a secant. And what I'm going to do first of all is rewrite this in terms of just the cosine. So it's 2 cosine of x minus 1 over the cosine of x equals 0. I don't like having this cosine down in the denominator. So what we're going to do is multiply both sides by cosine. So 2 cosine squared of x minus 1 equals 0. Now if we add 1 to both sides and divide by 2, we'd have cosine squared of x equals 1/2. Next step, take the square root of both sides. This shouldn't be right there. Take the square root of both sides, and now we have that the cosine of x is equal to plus or minus the square root of 1 over 2. The square root of 1/2 is not 1/2, nor is it 1/4. If we took the square root of the numerator, we'd just get 1. If we took the square root of the denominator, we'd get root 2. And then when you rationalize that, you get that the cosine of x equals plus or minus square root of 2 over 2. Cosine positive, cosine negative, so we're looking at all 4 quadrants here. The reference angle would be pi over 4, so our answers are going to be pi over 4 from the first quadrant, 3 pi over 4 from the second quadrant. In the third quadrant, we get this, and in the fourth quadrant, we get 7 pi over 4. Again, we have all 4 of the quadrants because we took the the square root back here. That's why we have the plus or minus. That's why we're looking everywhere for this one. Next problem. Cosecant is the reciprocal of sine, so what I can do in this problem is multiply everything by sine. 4 sine squared of x minus 3 equals 0. And now it's going to look a lot like the last problem. a note on this one that I didn't make in the last one. The original problem has 3 cosecant x. In other words, 1 over the sine of x. So what I know then is as I'm going through this problem, the sine of x can't be equal to 0. So if I solved it and I did get a value where sine of x equaled 0, I'd have to eliminate it because from the original problem that is limited from the domain. Okay, so back to the problem. Add 3, divide by 4, sine squared of x is equal to 3/4. Take the square root of both sides. So again, it's going to be a plus or a minus square root of 3 over 2. The reference angle where sine is equal to root 3 over 2 is 60 degrees or pi over 3. So x equals pi over 3 and 2 pi over 3 because sine could be positive root 3 over 2. But because it's also negative, we'll go down into the third quadrant and the fourth quadrant using those same reference angles. And we'll also get answers of 4 pi over 3 and 5 pi over 3. Next one, 2 cosine of x plus 1 equals 0. Subtract 1, divide by 2. Cosine of x equals negative 1/2. So cosine is negative in the second quadrant and third quadrant. The reference angle out of the first quadrant would have been 60 degrees or pi over 3. So put that reference angle here as well as in the third quadrant. Our answer in the second quadrant is going to be 2 pi over 3. And in the third quadrant, it would be 4 pi over 3. Next problem. And this one's going to be a bit more involved this time. There's a sine squared and a cosine squared. They're not added together, so this does not equal 1. One of the things that I can do here is I can get this entire equation in terms of just sine or just cosine. So one thing that I know is that since sine squared plus cosine squared equals 1, then cosine squared is equal to 1 minus sine squared. And I'm going to use this fact and substitute it in where we see that cosine squared. So rewriting this problem, it's 3 sine squared of x minus 1 minus sine squared of x equals 0. So now if we combine like terms here, 3 sine squared minus negative sine squared, that's a positive 4 sine squared of x minus 1 equals 0. Add 1, divide by 4, so sine squared of x is equal to 1/4. Take the square root of both sides, so the sine of x equals plus or minus 1 over 2. And from this, we can come up with all of our answers. The answers would be pi over 6 and 5 pi over 6. That's where sine is positive 1/2. And a negative 1/2, we'd be looking at the third quadrant, as well as the fourth quadrant to get these 4 solutions. Next example. This problem on the left is not trig in any way, but if we can solve this one, it's going to be a bonus to us or helpful as we look at this following problem. In factoring it, I know that 2x times x is x squared, and I need to multiply it to a negative 1, so it's going to be a positive 1 and a negative 1. But then when we add to get the middle terms, there's got to be a negative 1 there, so I'm thinking it needs to look like this. This multiplies to negative 1, multiplies to 2x squared, and then a middle term would be the negative 2x. So then if it solves like factors like this, then we would solve it or get solutions of x equals negative 1/2 and x equals positive 1. And the reason why I did that is because this next problem is going to look pretty similar to that. In this problem, we have a sine squared, a cosine squared, and a cosine. I don't want to have both sine and cosine in there. And since we have this cosine of x, what we're going to do is we're going to get everything in terms of cosine. So the first substitution, or the only substitution we have to make, is to take out sine squared and put in 1 minus cosine squared for that. So we have this. Let's move everything over to the right-hand side. So then 0 is equal to 2 cosine squared of x. Still minus just 1 cosine of x. Subtract 1 to get it to that side. And what we have is this equation with the cosine squared meets that same criteria that we had over there. If you compare those with each other, they really are the exact same thing, but now we just have the cosine involved with it. So in factoring this one, we're going to have 2 cosine of x plus 1 times cosine of x minus 1. Again, factored in the same way as the previous one. If we look at what I have factored here, compared to what we did in the previous problem, they are the exact same as each other. Going a step further, now we could solve this equation. Cosine of x equals -1/2. When we set it equal to 0, subtract and divide. This will give us solutions of 2 pi over 3 and 4 pi over 3. We just did that problem. And this one we get cosine of x equals 1. And the only place where this happens between 0 and 2 pi, notice the bracket versus the parentheses, is when x equals 0. So those are our 3 solutions to this problem. All right, next example, we have a few different trig functions, and I like to get everything in terms of sine and cosine. So if we rewrite this problem, tangent is equal to the sine of x over the cosine of x. And what I can do with this then is, unfortunately, not simplify by getting rid of anything, but the second term would become sine squared of x over the cosine of x. I want to combine these two terms that are on the left, which means I'd have to have a common denominator, which is going to be cosine. So if I multiply this numerator and denominator both by cosine, it makes it become cosine squared x over cosine of x plus sine squared of x over the cosine of x. And this is still all equal to 1. Now if we combine these two together, because they have that common denominator, we'd get in the numerator sine squared plus cosine squared. And I know that that's one of our Pythagorean identities. That's equal to 1. So we have 1 over the cosine of x is equal to, I don't know why I changed that value to 1, but it's equal to 2. If you cross multiply here, we get 1 is equal to 2 times the cosine of x. Next step, divide both sides by 2. So we have the cosine of x is equal to 1/2. And from this point we can solve it. We get x equals pi over 3. That's from the first quadrant. The other place where cosine is positive is down in the fourth quadrant. So if we draw that reference angle in there, pi over 3, I know that this other answer is going to be 5 pi over 3. Here's another simple one. We'll just go ahead and skip that for now. Next problem. 2 sine of 4x is equal to root 3. So if we divide both sides by 2, we get this. So the solution to this one, 4x is equal to, where does the sine equal root 3 over 2 but at pi over 3? And then in the second quadrant, we have another place where sine is positive. Put my reference angle in there. That would be 2 pi over 3. But this problem isn't done at this point, because that's what 4x is equal to. This 4 changes the period, which means it's going to oscillate a lot quicker. We're going to get 4 times as many solutions as we normally would. Because if I look down at this line I have written here in blue, this is 4x. To get x by itself, divide both sides by 4, and this first answer actually turns into pi over 12. If 4x is equal to 2 pi over 3, divide both sides by 4, we would get 2 pi over 12, which actually then simplifies down to pi over 6. We want all the answers between 0 and 2 pi, and right now these answers are both pretty small. So I'm going to go back up to this blue line, take this first answer we have of pi over 3, find a coterminal with that, in other words, add 2 pi onto it, and we'd get 7 pi over 3. And if we have the 2 pi over 3, add 2 pi onto that, we get another answer of 8 pi over 3. Again, this is what 4x is equal to. So if we divide this, say 4x is equal to this, divide both sides by 4, we get another answer then of 7 pi over 12. If 4x is equal to 8 pi over 3 and we solve that one, we get another answer of 2 pi over 3. Again, as I mentioned before, since it's 4x, we get 4 times as many solutions. Normally we would have gotten 2, and we only have 4 so far, so we're only halfway there. Add 2 pi onto these values again. So from here, we're finding coterminal. We always go back to this part where we took the trig inverse and then find the coterminal from here. So add 2 pi onto both of those values, and we're going to get 13 pi over 3, 14 pi over 3, 19 pi over 3, 20 pi over 3. And then if we divide those all, we will get the final answers of 13 pi over 12, 7 pi over 6, 19 pi over 12, and also 5 pi over 3. all 8 of those answers.